Binomial random variable represents the number of successes out of n independent trials. Number of successes out of n independent trials. If you perform an experiment n times, each trial is independent of each other. Every trial can result into either success or failure. All the trials are independent. Probability of success is constant. In that case, if you denote x by the number of successes, then your x is binomial. Now we got another random variable, which is called hypergeometric random variable, and this is pretty close to binomial. And the difference between these two is very, very small. And it's very important to understand the difference between these two. And the third one that I will discuss is also number of successes. This is also number of successes. So there is a very precise difference between the two of them. Now, in binomial distribution, there were 4 conditions. Number 1, you repeat the experiment n times, fixed number of times. Number 2, every trial was either success or a failure. And then the trials were independent and the probability of success was constant, right? This was the diagram. This was the diagram. You have this experiment, you can perform it many times, but you perform it only n times. Each time the trial is independent of each other. Each trial is resulting into either success or failure, where the probability of success for each trial is p. And in this case, if you denote x by the number of successes, here you say x has a binomial distribution. Now, when will these conditions be satisfied? I will give you a shortcut. Whenever you see a question where P is directly given, there is no other distribution where P will directly be given. So if you see a question where probability of success is given, it's binomial. Number 1, a shortcut. Number 2, look where you are selecting all of these 3 distributions that we will discuss today, binomial, hypergeometric, and Poisson. You will be selecting. If the selection is from infinite population, number of successes will be binomial. Infinite population. For example, in this question, you selected 8 samples of water from how many? Infinite many samples, right? If the size of the population is either infinite or not mentioned means infinite. Okay. If the size of the population is infinite and you are selecting n out of them, for example, 8 in this case, trials will be independent. Probability of success will be constant. If you are selecting out of finite and selection is with replacement, that means you select, you put it back. Then you select again, you put it back, which is usually not the case. Usually in real life, when we select, we don't select with replacement. We select without replacement, or we select together, which is equal to without replacement. So if the space is the overall population is infinite, usually you will push towards binomial. Now comes the second case, when the space is finite. Here is the second case. Now you have a finite space. Inside the space, you have a total of n objects, not infinite samples. Now you have finite samples, n samples. Out of these, some of them are successes, some of them are failures in the population. For example, I have this class, and from this class, I will select 5 students. And I will check out of those 5 students, how many are from mechanical engineering major. So my success is that the student is from mechanical engineering. Each student is either a success or a failure, right? From mechanical or not mechanical. I'm choosing 5 without replacement, right? Now, is this binomial? Again, my x is the number of successes. Is this binomial or hypergeometric? It's hypergeometric, not binomial. Why? Because the trials are not independent. Suppose I pick first student. What is the probability that this student is from mechanical engineering? Let's say in my class, there are 13 mechanical engineering students, to be precise. What is the probability that this student is from mechanical engineering? 13 divided by 35. Correct? 13 mechanical engineering students, total 35 students. The probability that this student will be mechanical engineering is 13 divided by 35. Now I pick the second student. What is the probability that second will be mechanical engineering? 29. You cannot tell until you know the result of first. What if the first one is mechanical engineering? 12 divided by 34. What if the first is not mechanical engineering? 13 divided by 34. So the second trial became dependent upon the result of the first trial. Trials are no more dependent. So whenever you are selecting without replacement from a finite population, the trials become dependent. And in that case, the distribution of number of successes is no more binomial, it is hypergeometric. So look at the question. Whenever we give you the question of hypergeometric, we will not give you P. We will give you the numbers that the space size is 35. Out of 35, I have 13 successes and I want to select 5. So we will give you 3 numbers. Number 1, we will give you the size of the space. Number 2, we will give you how many successes are in your space. And number 3, we will give you how many are you selecting without replacement. And these are the 3 numbers you need to solve any question related to hypergeometric. Like you need 2 numbers to solve any question about binomial. What are those 2 numbers? To solve any question about binomial distribution, you need 2 numbers. What are those 2 numbers? Wait 2 seconds. P and N. You need N and P. If you have N and P, your mass function is full and you can solve any question related to binomial distribution. Similarly, to solve any question about hypergeometric, you need 3 numbers. You need how many in your population, how many successes in the population, and how many are you selecting from the population. Yes. With replacement means that I have this 35 students. I will select 5 students, but I will select the first. Ask him to stand here, then select the second. Ask him to stand next to him, then select the third. Ask so I'm not replacing it back to the population. I'm selecting 5, but every time I select, the selected student is not going back. Every time the size of the population is going down. Whereas with replacement means I select, I check whether the student is mechanical or not, put it back into the population. This student can be selected once more. This student can be selected all 5 times. So that's what we mean by with replacement. With replacement means that the size of the population doesn't change. So the trials stay independent. Okay, so
does it need to be the same student that I select?
It doesn't need to be. It's random. It's random. It can be. Maybe, yes. So here is the scenario. The scenario is that you have a population, this bowl. In this bowl, you have K successes, N minus K failures. The total number of objects in this bowl is uppercase N. And you select small n from this bowl and you denote X by the number of successes. If this scenario is satisfied, in this case, your X will not be binomial. It will be hypergeometric. And if you are able to recognize that X has a hypergeometric distribution and you know what are those 3 numbers, small n, capital K, capital N, the remaining thing is to just plug in and get the answer. Plug in the numbers here, plug in the numbers here. If the mean is required, plug in the number here. If the variance is required, plug in the numbers here. If probability is required, plug in the numbers here. That's it. The most difficult part of any question from chapter 3 is to recognize that if the distribution is binomial or hypergeometric or Poisson. Again, I will repeat this process at the end of this chapter, that what is the difference between the 3 of them. So let us move on towards the problem solving. We already discussed what is K combination X in the previous class. Put your mobile in the pocket. We already discussed in the previous class that what is N combination K or K combination X or N minus K combination N minus X. You can find it on your calculator. The domain of X starts from something to something. You can just plug in the values and you will see that it starts from what to what. The mean expression is given to be as a function of those 3 numbers. The 3 numbers that I said you need to get from the question. The variance is again a function of those 3 numbers. You will get these 3 numbers from the question. Standard deviation is nothing but a square root of the variance. Let us see a question. Read the question. The question says that there is a batch of 100 parts from a local supplier. And 200 from a next state supplier. So how big is the total batch? 300. So this is your population. 300. How many of now read the question and see where are you interested. Wherever you are interested, that will be success. So continue reading. 6 parts are randomly selected. Look here. Pay attention to this word. Now, if I don't give this word, what will you assume by default? You will assume without replacement by default. For example, if I tell you I come into this class, I want to select 5 students. Will you assume that I'm selecting 5 students with replacement or without replacement? Of course, without replacement, because I need 5 students. So if the method of selection is not mentioned, you will assume by default without replacement. Now, this 6 parts are selected without replacement. See, where are you interested? I will highlight that. Where are you interested? Selected parts are from local. So your success is that the selected part is from local. How many successes are in your population? How many failures? 200. How many are you selecting? You got the 3 numbers. You got n, you are selecting 6. You got 100, the number of successes in your population, and you got 300, the total size of your population. That's all you need. That's all you need. Now read question number 1. What is required? What is the probability that out of 6, how many are successes? 2. That's it. Just plug in. Here is the probability mass function of hypergeometric distribution. I will plug in the values in this one. When I plug in the values in this one, my k is 100, my x is x, my n minus k was 200, my n minus x is 6 minus x divided by 300 combination 6. What do I want? Probability of x equals 2. Just plug 2 into this one. So it is 100 combination 2, 200 combination, 300 combination 6. Calculator will do the job for you. From this moment onwards, get these 3 numbers from the calculator, and that's it. Read the second question. Let me write the mass function here. (100 combination x, 200 combination 6 minus x over 300 combination 6. Just plug and get the answer. Read the second question. What is the probability that who can tell me what is required in terms of x? Less than or equal to 2. Is he right? At most 2 means 2 or less. So this is probability of x equals 0 plus x equals 1 plus 2. Again, plug in, get the answer. Yes.
Capital N, small n. What is the meaning?
Small n is the number of people I'm selecting from the class. Capital N is the total number of people in the class.
The K is the number of successes.
No, number of successes is x. That's random variable.
The
K is the number of successes in my population. The total number of mechanical engineering in this class. The total number of parts from the local supplier in my whole population of 300. Now, one thing you need to be careful of, just one margin of mistake is still there. Like in this question, when I was asked to get the probability of less than equal to 2, I started with 0. I started with 0. Does 0 really belong to my domain? You need to check. Maybe it does, maybe it doesn't. Put the values in here. The domain of X starts with maximum out of 0. And what is n plus k? My n was 6. My k was 100. 106 minus 300. Minus 194. Which one is bigger out of 0 and minus 194? So the domain starts with 0 and all the way up to which one is smaller out of 6 and 100? Which one is smaller out of 6 and 100? 6. So the domain starts with 0 all the way up to 6. Here 0 to 6, but in some questions it might start from 1, might start from 2. Depending upon the values of n, k, and capital N, it might start from 1 to 6. It might start from 0 to 5 and so on. So plug in the numbers in this domain and check. Here, luckily, it started from 0, so I started from 0. In case your domain starts from 1 and you include this probability and you plug in these values in the PDF, the combination will give you a negative answer. That is an early indication that you are doing something wrong. Okay? It will give you a negative answer or undefined answer. For probability of X equals 0, it will give you undefined or negative answer. So that's an early indication that X equals 0 might not be in the domain. Yes. Yes, if X equals 0 was not in the domain, you will start with wherever the X is starting from. Maybe starting from 1, maybe 2. I will not do these remaining parts. You have done these in the previous class. For example, yes.
Question 2.
Same 6. It's continuing from here.
Okay.
It's continuing from here, this statement. Top 2 lines that 6 are selected randomly without replacement. Let's quickly see what's required and you can solve it yourself. Part 3 says, what is the probability at least 2 are successes? How can you solve it? 2 plus 3 plus 4 plus 5 plus 6, or complement 1 minus 0, 1 and 2. Part 4, what is the probability that all of them are successes? Six, not 7.
Yeah, but then we go same.
No. When I say 0, 1, 2, 3, 4, 5, and 6, these are the possible values of X. For example, if I choose 6 students from this class and note down the number of students out of 6 who are from mechanical engineering, what are the possible values of X? Can I have 6 students and none of them from mechanical engineering? That means X equals 0. X is actually the number after choosing. Okay. Yes. None of them from the local supplier. What is the probability that all of them are from local? X equals, this will be 100, choose 6, 200, choose 0, 300, choose 6. What is the probability? No more than 5 from the local supplier. No more than 5. Better to use complement. You already found probability of X equals 6. What is the probability between 3 and 5 from local supplier? What is the probability that the number of selected from local supplier is either greater than 4 or less than 6? Either greater than 4 or less than 6. Or union, not intersection.
So
So apply the union formula. A plus B minus, what is the intersection between greater than 4 and less than 6? Only 5. Only 5 is the number that is greater than 4 and less than 6. Given that less than 6 parts in the selection from the local supplier, given that X is less than 6, do you get how I make the statement out of the question? Given that less than 6 from local supplier, what is the probability more than 4? Apply the conditional probability formula. What is A given B? Intersection over less than 6. Now, for less than 6, will you find it directly or complement? Better complement. For the numerator, it's what? Only 5. So probability of X equals 5 divided by 1 minus probability of X equals 6. Yes.
I find the domain, right? And only 6. So I couldn't find the complement of.
Yeah. Again, for the middle part, you mean this one?
Yes.
Of course, complement will be easier. Much easier.
I mean, it's union, right? So
yeah, you can also, yes, you can also find the domain and shortlist those numbers which are in the union and simply add those probabilities. Yes, exactly same answer you will get. What is the mean? Read the question. I gave you the answer. Read the question. The question says, what is the expected number of selected parts that come from local supply? What is the expected? Expected means what? Always. Mean. What is the mean of selected parts coming from the local supplier? Formula. This will be given to you. So plug in the values. What is N? What is K? 100, sorry. 100 over 800. What is the standard deviation? This will be given to you. N times K over N times 1 minus K over N times. Yes. So just plug in N small n and K and capital N and you get it, the positive. And that's it. This was hypergeometric distribution. Again, the trick is only two things. Number one, to recognize that X is hypergeometric. And number two, once you are sure X is hypergeometric, you need 3 numbers. Small n, K, and capital N. Once you have 3 numbers, translate every question in terms of probability, solve it. Solve it the way you solve it in chapter 2, exactly the same way. My watch is not working. No.
Take a break.
I will finish. No, just give me 10 minutes, I will finish. Last distribution, Poisson distribution. A Poisson random variable again counts the number of successes. Binomial was number of successes out of n independent trials. Hypergeometric was number of successes when the trials are not independent. They were without replacement selection. Here you are interested in number of successes per unit. Per unit. So whenever you see per unit, per millimeter, per second, per kilometer, per kg, if you see per unit, that's Poisson. Okay. Whenever you say per unit, that's Poisson. Any unit. The unit can be, here are many units written. The unit can be time. The unit can be space. The unit can be weight. It can be volume, centimeter cube. It can be area. Volume is not cube, is it? Area is centimeter cube. Or it can be distance, meters, kilometers, centimeters, whatever. Unlike binomial distribution, now see the difference between the 3 of them. Unlike binomial distribution counts the number of successes out of n independent trials. Hypergeometric distribution counts the successes out of n trials without replacement. Poisson focuses on number of successes per unit. Per unit. Key is per unit. any unit. Look at some of the examples. Number of customer calls you receive per hour at a call center. Suppose you're sitting in the call center and you are receiving calls from the customers. So each hour is 1 unit. So how many calls do you receive in the first hour? How many calls do you receive in the second hour? How many calls do you receive in the third hour? How many calls do you receive in the fourth hour? So number of calls received each hour is a variable, is it? Every hour, the number of calls is different. That's a variable. And this variable follows a Poisson distribution. Number of accidents per day. Look at the bold. The key is the bold. Per day, per hour. Number of defects per square meter. You are making metallic sheets of 1 meter square, and you're trying to see that what is the number of defects per square meter of this fabric sheet or metallic sheet. Number of air bubbles per liter of liquid per liter. Again, the key is what? Per unit. So if for any question you are interested in number of successes per unit, then the distribution will be Poisson. And in Poisson distribution, there is only one parameter. In binomial, there were two, N and P. In hypergeometric, there were three, N, A, and uppercase N. In Poisson, there is only one, which is the average number of defects per unit or average number of successes per unit. So here, the Poisson random variable X counts the number of successes per unit. Again, number of successes, but per unit. Here is the diagram. You have a space of infinite happenings. Think of you are sitting in a call center and you are receiving calls. How many hours you will be sitting till, not in a specific day, but how many such hours do you have? Infinite many hours. How many calls did you receive in the first hour? 2. How many calls did you receive in the second hour? 0. How many calls you received in the third hour? 4. Fourth hour? 3. Fifth hour? 1. Sixth hour? 2. Seventh hour? Something else. Eighth hour? Something else. Next day, ninth hour? Something else. And you continue. This is a random variable. Each hour you are receiving different number of calls, right? This is the random variable. And this random variable X, which is number of calls per hour, is Poisson. What will be given to you is the average number of calls per hour, the mean. We will give you the mean in question. We will tell you that number of calls per hour follows a Poisson distribution, or we will say that we are interested in number of calls per hour, where the average number of calls per hour is, let's say, 2.3. On average, you expect 2.3 calls per hour. Now find the probability that X is less than 2, more than 2, between 3 and 5, greater than 12, and many types of questions. So the least information will be given in this type of distribution, where we only need average number of calls per hour, average number of successes per unit. And the notation we will give to that is lambda. Lambda is the average number of successes per unit. Then again, once you recognize two things, number one, that X has a Poisson distribution, and number two, what is the value of lambda? Once you recognize these two things, it's again plug and compute. Plug and compute. That's it. No complication, just plug and compute. Yes. Lambda will be given in the question. I will show you how lambda will be given. X is the variable, number of successes. X is the variable that will be required in the question. Read this question and see how much information is given to you. Just one line. What does this one line say? A customer service center receives on average 3 calls per hour. Find the probability that exactly 2 calls are received in next 1 hour. Now, what is X here? Number of calls received per hour. What is the distribution of X? Poisson. With lambda. What is lambda? Lambda is the average number of calls per hour, the average of X. What is the average of X? It should be given in the question either directly or indirectly. What is given it here? 3. You can just plug this 3 in here and you will have the full PDF. E to the power minus 3, 3 to the power x over x factorial. Now, pay attention to the domain of x again. It starts from 0 to infinity. Now, if we ask you a question of probability of x equals 2, what will you do? You will plug 2 in. Correct? If I ask you less than equal to 2, what will you do? 0, 1, 2. The problem will happen when I ask you greater than 2. Now you cannot solve it directly. You are bound to use the complement rule. You cannot solve it directly. Yes.
How did you find that?
I did not find x yet. X is the variable yet. X will come from the question. Now read this question first. Yes. Here the required thing is this. What will you do? E to the power minus lambda, lambda to the power 2 over 2 factorial. Answer. Now read the question 2. What is the probability that at least 2 calls are received in next hour? Can you solve it directly? You cannot, because there is no upper bound of the domain. X equals 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus all the way. You cannot solve. Bound to use the complement. So this will be 0 and 1. That's it. So 0 will become e to the power minus 3, 3 to the power 0 over 0 factorial. 2 is included on the upper side, so it will not be included here. What is 0 factorial? 1. Next question 3. What is the probability that the number of calls received in 1 hour is between 2 and 5? So between 2 and 5 includes? Inclusive. 2, 3, 4, and 5. What is the variance of the number of calls received in 1 hour? Variance, go to the expression and the expression will tell you that the variance for this distribution is the mean. So it's the same 3. If I ask you for standard deviation, square root of 3. Extension of Poisson distribution. What if I ask you a question here? Instead of 1 hour, I ask you what is the probability that you will receive 2 calls in next 2 hours? I change the unit. What will happen? Instead of 1 unit, I ask a question about t units. 2 units. Lambda will double. That's it. X will still remain the Poisson. Lambda will be adjusted according to how many units do you want. And this is what is discussed here. If you are interested in 1 unit, it was simply e to the power minus lambda, lambda to the power x over x factorial. If you are interested in t units, the PDF will become, the mass function will become e to the power minus lambda t. For example, if I'm interested in number of calls per 2 hour, but the average is given per hour. What was the average given to me? 3. So what will be the average per 2 hours? 6. So e to the power minus 6, 6 to the power x over x factorial. Simple. If I'm interested in half hour, next 30 minutes, divide lambda by 2. So that will be 1.5. If I'm interested in next 5 hours, multiply it by 5. So that's what we call Poisson process. So any rescaling of Poisson is again Poisson. So if you want to rescale, you can rescale Poisson. Read this question. Flaws occur at random along the length of a copper wire. You have a copper wire production. It is producing copper wire, and at the length of copper wire, there are flaws. They occur. Suppose that the number of flaws follow a Poisson distribution with mean 2.3 per milliliter, 2.3 per millimeter. Lambda is 2.3 per millimeter, but the question will not be per millimeter. Look here. We give you the lambda per millimeter and ask the question per 2 millimeter or per half millimeter or per 3 millimeters. Just rescale the lambda. No complication. First question has no complication. Determine the probability. Let me first write the distribution of x. X follows Poisson with lambda equals. Better to write the units now because next question is double the units. Lambda is 2.3 per millimeter. What is required? Equals to, less than 2, more than 2, less than equal to what? 2. Exactly 2. So this will be e to the power minus lambda, lambda to the power x over x factorial. X is 2. X comes from the question. Remember, x comes from the question. Read part 2. Determine the probability of at least one flaw. Probability of per. Yes. But before that, complement. So this will be 1 minus e to the power minus 2 times lambda, 2 times 2.3 to the power 0 over 0 factorial. Wherever there was lambda, make it 2 times lambda. What is the expected number of flaws per 5 millimeter? 5 times lambda, which is 11 point something. 11.5. I think. I'm not sure about this. Check it. We're done. We're done with chapter 3. This is what we discussed in chapter 3. Pay attention. On to the screen. We started this chapter with the general definition of a random variable. We said a random variable, it assigns numeric values to the outcomes of a random experiment. A discrete random variable can take only countable or countably infinite number of values, whereas a continuous random variable takes uncountably infinite number of values. We will discuss that in chapter 4. Then we discuss the probability mass function. Probability mass function is a function or a table that tells you about all the possible values of x along with their corresponding probabilities. Following two conditions they satisfy for probability mass function. That is that the sum of the probabilities should be 1 and each probability should be greater than or equal to. Expect sometimes a question where we'll give you the table and one of the probabilities is missing. How will you find that? You know that the sum is 1. You should know that the sum is 1. If one of the probabilities is missing, then take the sum of the remaining and subtract it from 1. That should be that one probability, right? So maybe in one of the questions, we give you a table of mass function where one of the probabilities is missing, or one of the values of x is missing, and we give you the mean. Expected value of x is given, but the value of x is missing indirectly. Indirectly, you might have to solve. Then we talked about 3 special discrete distributions. One of them was binomial, was hypergeometric, one of them was Poisson. Read this carefully, very, very, very carefully. We said binomial is said to be a random variable x, which takes the number of successes in n independent trials. What was the key to identify that x is binomial? The number of trials is fixed and independent, and the probability of success is p. Here is the key. Here is the key. Because you don't have chapter 4, if you are not sure between the 3 distribution, look for p in the question. If p is given, it's binomial. Because in hypergeometric, we will not give you p. We will give you n, K and N. We will not give you P. In Poisson, we'll give you lambda, average, not P. So if P is given and number of successes is required, binomial. If you see the word without replacement and number of successes is required, hypergeometric. If you see the word per unit, per millimeter, per liter, per square meter, or whatever, per second, that means you are interested in Poisson. So next class, we will solve some questions from exam, not from the textbook, from exam. 6 questions from 241, 6 questions from 233. Then the class after, before the next class, you will see, I will upload these slides on Blackboard, but this will be filled. I will fill the recommended problems. This will be probably 20 questions, between 20 and 25 questions. I will fill that. And I suggest you start preparing from this weekend. From this weekend, start solving those. How many questions did I give you in total? 25 plus 15. I gave you 40. 40 plus 20, expect 20 from here. Total 60 questions. Just solve those 60 questions and hopefully you will be fine.